Hello, everyone. Thank you for coming for the third day of the Intro to Python workshop. I hope you enjoyed the past 2 days. In today's course, we'll spend more time to recap what we have learned in the past 2 days. So you will be more familiar with what you have learned and practicing more and how to coding on your own. So we're starting to warm up and let's go through what we have learned from the past 2 days. So in day one and day two, basically we're starting from those basic data types, strings, integers, float, and we know about Boolean. There's some rules, priorities, and we just learned another collection data type that's frequently used, which is the list. We learned from yesterday's. Okay, and we starting to know about this, how to make decisions and logical expressions with those arithmetic operators. And you can have those if statement as the basic building blocks for most of the programs to ask Python to make decisions if some conditions met. Okay. And we learned about the loops. So it's doing recursive works. We learned about the for loops and also the indefinite while loop yesterday. And we're starting to use those built-in functions like embedded in the Python distributions. You can just easily call these functions like range, print, and list. So that is, you can just take advantage from those built-in functions. And also we're starting to know how to reading and writing files, which means like reading from the existing files and into the Python and also memory. So you can process the data. And once you finish, you can also write it to the files and update it. Okay. And so let's just quickly go through those things we've learned. So as you can see here, we know how to denote variables. For examples, here's we have variables on the left of these equations. So which is variable 1, v1. So you can see from here, because it's double quotations, which means this is a string variables. And this is integers, and this numbers with digit, there will be a float data types. And it can also store this logical expressions, which is will return a Boolean variables. So there will be only true and false in this category. So this one is the true statement. So v4 variables will be a Boolean value with true. Okay. And the if statement, like shown here, we decided this snow underscore outside to be a Boolean variable called true. So this if statement saying if true, then what the program will do is print stayed home. Other conditions will go to the else part. And if this conditions if this line doesn't match, they will go to this else part and print go to work. So that is the if statement, like make those decisions and logic based on the logic. Okay. And we also learn about loops. So here is examples for a while loop. So it's basically indefinite, but when some criteria have met, you can break the loops. Okay. So here, like this conditions, we're starting from assigning a variable. So this I is an accumulative variable starting from integer 1. So as you can see, like while I is less or equal to 10, you will first print these integers. And then what you do is like adding 2 to this accumulative variable I. So they will keep adding 2 until when? Until I is greater than 10. So this loop will stop and break. And it will print done in the final. So that is how the while loop works. And this one is like you give this loop an early exit by calling this break keyword. So here is also like we have I equals to 1 at the beginning and it's accumulative. When so this while true is giving these conditions. So if I is greater than 10, then this loop will break. And then they will print I and additional, adding to additionally. Finally, once everything is done, then they will print done. So this is an early break to end this while loop. We also learn a different types is more usual ways we do is the for loop. You can iterate every component inside like a collections for every characters in the strings, for every component in the list, something like this. So for here, in these examples, you can see we learn about this range functions. They will give you a list of integers from the start to the stop -1. And the third parameters here will be the break, which means will be the step that will be the even skipped for this list of integers. So every component here is how printed out. And finally, when the numbers reach, which will be number integer 9, then we'll print done, which means the loop has already ended. Okay. Another keyword inside the loop, which will be the continue. Continue means you can skip the current cycles, but left the rest of the loop to keep going. Okay, for this example shown here, so we give a accumulative variables integer I, and also going through 1, 3, 5, 7, 9. Okay, and when we calculated for, do you remember this one? This will be the modulos. If the remainder of the division to 3 equals to 3, then they will continue, which means they will do nothing but go to the next step and then print the current I values. Once this all stuff has done, they will print done. Okay, so you will see different ways like pass, continue, break this stuff to manipulate how the loop will go. Okay. Let's go through this in more details. So these are the 3 main keywords we've learned from the past 2 days, and especially in the loop sections. So break is the statement alters the flow of the loop and will terminate it once the specific conditions is met. So they will break, which means that they will not go to the next component inside this loop. Okay. Continue with means they will skip the remaining code inside this loop for the current iteration only. So this loop is still going, but just a stop for these cycles. And pass is sort of a keyword that will like holding the space, like means do nothing, but just let the flow keep the loop keep going. Okay, it's just like a placeholder for future code. For example, if you don't want to do, you will go through these cycles, but not doing anything, you will put pass here.
That's an example of difference between continue.
Yeah, we'll go through right now. Okay. So here is, you can know that we are going iterating over a list of strings. So you will see there will be 1, 3, 5, 7, 9, right? Given this range output. Okay. So these lines, we give them a condition. The condition is a if statement. What do? Is they calculate the division these numbers by 3 and see if the modulus, the remainders, is equal to 3. If this condition met, they'll skip these cycles but go to the next one. Okay, so what this output would do, see, you can see So they will, so you can see the output, the printed integers will be those that is fully divided by 3. But those is not, which means they will have remainders. They continue but not print. Okay. So this is what the continue will do. The keep the cycle going, but just keep the current one. They skip 1, 5, and 7, but only printed out those fully divided. Okay. So let's see another examples for pass. This the same thing. We're still going to the same list of integers 1, 3, 5, 7, 9. So also we do division by 3. Okay. So this conditions is saying like if this is some remainders equals to 3, we'll pass. And otherwise we'll print this integers. So they will pretty much doing the same thing. Yeah.
So for the class, you just need the else.
You don't, but for else part is not necessary. You can also just like print this one, putting here. I just want to make sure like the if is more clear. Okay, it's the same thing. So this will give you the exact same output like the continue one. Okay. So you can have questions now. The logic.
Like so,
Mhm.
So the if else statement, if it's like, for example, 3 got fully divided by 3
Mhm.
and it pass.
Mhm. Which means this divided by 3. So it's not doing anything, but you need to get something here, right?
But how is 3 getting to like else print I? Because it definitely meets the first if statement,
Mhm.
but why comes into else?
Okay. Let's see how it goes. And you see the difference now. Which means they are not skipping this loop. They are still going, right? So the only difference here will be continue and pass. So the continue, if this is not fully divisible by 3, they will skip but not print, right? Not going for this cycle. They will just go to the next component inside the loop. But if you put pass, they keep going. They're still printing,
Oh,
right? Okay. But if you add one of this, like I just showed, it's different things. Otherwise, they will print. But this one, they will give you the exact same output than the continue. Yes.
I'm just like put for the pass, I just like split it up a little, and then I just put print right beneath the pass, but without the else,
Mhm.
and it just printed 157.
157. So you put print down below the pass. Yeah.
Yeah.
So you see the indentation actually matters. Yeah. So which means in this way, they will print those that meet the criteria for the current cycles. Yeah. And if this indentation level is here, then it's different stories. Right. Yep. So that's different keywords you can use to manipulate what conditions you're trying to skip, what conditions you wanted to let it go, and what conditions you might want an early break of this loop. Okay. So we just have a good example showing the indentation is the important part for Python coding. Okay, so in Python, indentations refers to adding those white spaces you just see. Like we got this one in different lines, right? So the default will be 4 spaces, but it's also depend on your Python editors, how you design it. But default is this one. Okay, so the indentation basically give you an idea, the block of the code. We'll go to this very soon. Okay. So you can think about this in the way like when you see several lines, they are on the same indentation levels. They will be on the same block or on the same level of the execution for Python. So this is the way to telling Python interpreters. So this part of the code that belongs to one block. Okay. So like we can go from this examples. So we assign an username to be like this. This is like a strings. Okay. So this is the variable assignment. You give them a strings. And then we're starting to do those string validations or user validations, which means you'll give Python some conditions, asked Python to make the decisions for you if this username is valid or not. So you can see the first conditions we want to check is the length of the usernames. So we'll make sure that the username's length is between 10 and 18. So if this criteria met, we add another additional conditions inside this condition when this condition is met. So we'll check the first letters of this username is the first letter. Remember the index systems we learned yesterday. We go to the first place and see if this letter is a uppercase, is in the uppercase form by calling this isUpper method. So if this condition is true, I'll print valid. Otherwise, they will print invalid. So when this condition met, which means they will also check for lengths, also check for the first cases. Okay. And then this else is like when the length doesn't met this criteria, they will go directly printing invalid. So you can see there are several building different indentation levels in this coding block, right? So the base one would be base label will be the nose indentations at the beginning. Okay. And then we're starting to do if statement. And then we got this second levels for building block. Okay. So which means this if until this else. So here they are doing the same purpose. So this purpose is to check if the first letter is an uppercase. So this is the building block 2 is doing. The third levels inside will be printing those decisions. Okay, there will be the block 3. And this if and else, they are on the same levels. There's 0 indentation levels. So which means they were doing the same thing, which is checking the length of the username. Okay, from this if to this else. So you can see from the indentation levels, you will quickly browse through and see when this coding block ends and what is the main purpose for this block of code is doing. Okay. So that is how indentation works in Python. And several times when you got arrows racing, they will tell you there's indentation levels. Sometimes which means like they don't know like when this building block ends and why you put this thing in this level. So that's the Python interpreters will checking and telling you if there's error occurred. Okay. So let's go for an examples for nested loops. So this is also a good one to see those how the indentation works and also go review the loops and nested loops we learned yesterday. So here the first level, the outer loop would be going over the integers from 1 to 2. Okay. So this is the first iteration. And for these two components, for each one, we're going through another cycle, which will be the inner loop shown here. You can see J will be including 3 digits, will be 1, 2, and 3. Okay. And then and then it will print the multiplications for I and J. And once you, for every J components ends, I'll give them an ends to be a 1 space empty space. Okay. So why we put this is because you remember the print functions, the default will be going to the next line after the printing. We want to make sure they are printing on the same line. So we added this end parameters to be empty space. Okay. So this print will be inside the J's, the inner loop. So once the inner loop is finished, I'll print an empty strings, okay, for every component in the outer loop. And finally, when this nested loops is finished, I'll print end of the loop. Okay. So let's see how it goes. So you can see exactly what we want. We're going through. The first line will be 1 multiplied with 1, 1 multiplied with 2, 1 multiplied with 3. So there will be the component inside the J. Okay. And then once the one of the J cycle done, we're going printing this stuff. We'll go into another line, and then starting to I equals to 2, and 2 multiplied with 1, 2 multiplied with 2, 2 multiplied with 3. Finally, this nested loops ends, and we'll print end of the loop. Okay. Any questions so far? So you see the nested loops, they also showing this indentation stuff. So which means these are in the same cycles. And then the outer loop will go into the end. Okay. Questions? No. So let's review another collection of data type, which is the list we learned from yesterday. So just a quick, really quick wrap up. So list is you most of the time is used to store multiple items in a single variables. So this is the data types that built in Python to store a collection of data, which means you can store a collection of strings, a collection of integers, and list also allow you to store different types of data, which means you can have a list that include both integer, both strings, float, and also list could store another list inside as well. So it's pretty much variables you can put every component inside of making them a list. Okay. So let's go through these examples. So we have a list of strings variable. So this variable represent this list, which will be the name list, including Mike, Sam, and Tom. So these are all strings. So I call this variables to be list of strings. You can print it out. And list of numbers, I put them into float. So there will be a list of numbers. Okay. And you can also have mixed type. You can have strings, float, and even another list inside. Okay. So when you print it out, they will show exactly what we expected typing here. So strings, list of numbers, mixed type. Okay. And if you want to add additional component to a list, you can very easily call this append method to add additional items to the current list. So we have a list of strings to be this one, remember? So there's 3 names inside, but want to add another person's. So I just add with append with Alice inside and then print it out. Okay. So you can see now, yeah, the list of strings, they will become for a component. And remember, the append items will always go to the last. Yes.
Could you do it, do it sort of in the middle? Is it like?
You want
add
to
something
insert?
in the middle or Insert it. in the beginning?
I don't recall like you can add to the beginning. So far, I don't recall any method to do that. Yeah, but you can change the component. That is possible. You might check there's a method called insert, but I'm not sure if that's applied to a list. Yeah, so they might be. Okay. So that is the basic manipulation for list. So now list have several features shared with rings. There, you can also think about they are both the data types that with collection of data. So you can access specific items to inside a list by the same index systems in the strings, okay, which will be this one. So you have a bracket and you have specific index for this one, for the list. And they will go to the second place inside list by calling the integer one, okay. So if you call this, we will first print the list of strings we just created. And then we go to the first place will be same, they're popping out. So the index systems is easy for you to access the specific data that's inside, okay. So the index systems is also could be nested. So remember we have a list of mixed types we previously denoted in here will be the list of mixed type. So this mixed type will include strings, integers, and another list. So for this one, for this lines, we're going to the third place, which will be a inner list. And we're going to the first place inside this inner list and show this with the print functions. Okay. So once we call this, we'll first print it out the list of mixed type. And we're going to the third place inside this list. And inside this inner list, we go to the first place, which would be the name Mike popping out. Okay. So index systems is really useful when you want to locate specific items. And it can be applied in the nested ways by just append additional index with orders. Okay. And let's go and review some of the index systems with this one. So you can remember we have a list of strings which include 4 names. So I wanna print out the last starting from the second place and print to the end of the list. Okay. I just wanted to ignore the first one inside this list. I could just call this index with starting on the left side of the column and then left the right-hand side to be empty. So the default setting will go to the end of this list. So what this will give you is we first print out a whole list and we want to print from the second place, which will be from here to the end that will show up. So you can just call this column and not give them the ends, the stop point. The default setting will be go to the end. Of course, you can give them additional 1, so they will print 2 names inside. It will be 1 to 2. Okay. So we've go through the index systems. So another specific features for list is that list is mutable, which means you have the index systems, you know which component at specific locations, and you want to change this item to another values, you can just do it by directly assign variables inside. So we have a list of numbers, which include 3 float numbers inside. And I want to change the second place to be 0. I just call the index and then directly assign with this operator equal, and then change them into the current float, and then print the new list of numbers. So let's see this one. So our original list of numbers will be 1.0, 3.1, 4.2. But I want to change the second place into 0.0s. I just call this index systems, and you can see the returning, they will change in place. So the list will be changing into 1.0, 0.0, and 4.2. So this is the specific features in list. And this features is not applicable in strings. Okay, so that's a specific features for list. Okay. So there are several similarities between list and strings, and we can even convert a list into strings. Remember, we learned about the join method in the day 1 classes, trying to manipulate those strings. So we can create a list of strings by merging this list of strings, calling the join functions. And remember, inside this double quotation mark before the join method, which means the delimiters when you're trying to join different components. Okay, so let's see what this will give us. So we first print out the list of strings, which will be so let's see. Before the list of strings will be like this, 4 names in the list. But things I call join, so this list will be joined together into one strings, and these strings will be delimited by this comma separators. So this type is a strings, and remember, we can always check what specific data type this object is by calling the type functions. So I just call type and checking for the list of strings, and then they will return this values telling you this list of strings has already be converted into strings. Okay. And we can also do this different, trying to reverse into list, but then might show some different that's going through this. So we got this list of strings, list 2 strings, okay, into this, put this one into the list functions. So list function, you can see this one, the list with a parenthesis. So anything you put inside this, there will be changing into the format or the data type of list. Okay, so let's see what this will give us. So you can see, so this list 2 string, this whole list will be separated for every characters. So it will include digit, letters, and even the comma is also one character. So they will be split completely into several components. Okay. But this is what we want. We want this name to be compact into one specific items. So this one will need to use another method called split. So split functions, split method. So you can see here's, you can call split and put a list as the things you want to change. And then what you put inside this parenthesis will be the delimiters to split the component inside this strings. Okay. So in this way, we can see this, these two strings, the original strings has already been split by when this list encounter a comma, the comma inside. So they will be pretty much separated into compact names into a list. And this list two strings with split method will give you a list object by calling the type functions. Okay. Question so far? So we are trying to use different method and different functions to change between list and strings. Okay. So now we've pretty much going through what we have learned in the past 2 days. Okay. So that's starting from today's new stuff. So we're going more about the reading and writing files, and we're starting to learn functions, which will be the really important part in coding. And another, if we have time, we're going through another data type, which is a dictionaries, which will give you a index systems of collection of data. Okay. So today we'll also have some assignment, but for those students you taking the class for credits, for day 3 assignment is not mandatory, but I will encourage you to finish it. So again, you just need to give me the assignment for the past 2 days and by the end of next Friday. Okay, so that is for credits. For day 3, I encourage you to do so, but it's not mandatory. Okay. So let's go through the reading and writing part. So remember we going quickly about going through those with open with method to open a file, create file in a writing mode and reading mode yesterday's. So those with statement initiate the context managers to open the files and manage this file resources as long as the context is active. Okay, so you can see, and once it opens, so loading the data into the operating systems, and you can do additional handling in the memories. And once you've been done, and you are calling the operating systems to writing into the disk. Okay, so that is what the context manager is doing. So let's just go through with examples. So these lines we call with open, which means we'll open these specific files. If these files exist in this directory you're opening it, they will open it. If it's not, they will create this for you. Okay. So always remember they will override anything if this already exists. Okay. So with open the text.txt, these files, and we need additional parameter here with W, which means is the writing mode for this context managers. So these things, we're treating this as a variable called f. Okay. So what we do to this f is I'll ask this context managers to write hello users and then give to the next line. Okay, remember the backslash and end represent next line is the special characters. So once we execute this stuff, they will not showing anything in this IPython Jupyter Notebook interface. But if you go to the place you store for these files intro to Python day 3. So for example, I store on my desktop. So this file will be showing up. So you can see I just modified these files by adding to hello users that I just wrote. Okay. So remember there will be the same path you operate this Jupyter Notebook. Yes.
And then if you want to put in a different directory, you just have to put the path in.
Yes, you just need to put the direct absolute path inside the strings. Okay. So now we have already created these files. Now we're trying to do things is reading this file back in. So we're still calling the context managers with open this file. We know this already exists, right? And also I'm calling this as an F. And once I read this, I'll iterate over different lines into the for loop with the for loop. So here you can see is for every line inside this context managers, I'll print the line strip with empty space. Remember the strip method is to get rid of those empty spaces at the beginning, at the end of this specific strings. Okay, so I'll just execute this one. So they will read these files, and if there are several lines, they will print several lines. But now we just have one, so they will just print it out here. Okay. So this is the context managers reading and writing files too. Okay. So right now let's going more deep about how to practice this reading files. So I have a task here for you, and please create a file. So this is one task, right? Create a file that store the following sequence, like here, example 1, in FASTA format. So if you are working in biology field, you might know the FASTA format will be exactly like this things, and with the tag to be seq1 and seq2. So the tag will be this one with this greater than mark, and then the record, another tag, another record is different lines. So, and then read the files and print only the sequence. Okay, so you can see there are different tasks. Create a file first, writing things just like what I show here. And then once you create it, and I want to read these files, but only print it out this one. Okay. So you can do, let's see, let's going through, we can. So I'll just, because there's only 3 records, so I just first store the sequence into this 6 as a list. So I put this one, copy and paste inside. There will be a list of 3 strings, 3 sequences. Okay, I'm starting to writing the files by calling the context managers. I'll open this and created the sequence.fasta. So this will be the file name in the writing mode. Okay, and this one I call this context manager as f out inside this coding block. Okay. And then I'll iterate over every record 0, 1, 2, 0, 1, 2. And then when going over these items, I'll do this with a range functions. Remember, range will be calling integers. This good way to give you the index for that position of that component. So I'll range the length of the sequence, which will be 3, right? So there will be 0, 1, and 2. There will be the index of the 6. So for every index inside, I'll first write the tag. The tag will starting with the greater than seq this strings. And then I'll go with the index I, but remember I starting from 0, I want it to be starting from 1. So I'll adding 1 to this index. And since this stuff is an integer, they cannot be concatenated with other strings. So I need to do casting by calling the string functions to cast this integer into strings. So this will finish, for the first component will be greater than sig1. Once I finish, I'll go to the next line. So I'll go to the next line. In the next line, I'll write the sequence. So the sequence will be calling this one with index, specific index for that record. So this will be this component, and this component. And once I finish writing, I'll go to the next line for the next record. Okay. So once we've gone through these programs, this file will be created. Okay. So let's execute this part first. So I'll first created this file calling sequence.fasta. Okay. So you can go to the same directory on the IPython notebook and you open these files, they will give you exactly the same things like I just showed. Okay. So I've created these files. Now I want to read this file back in to this interface to make changes, do some additional work for these records, right? So we need to read back in. So I'll execute the rest of the code. So this, let's go line by line. So we'll open these created files. So this time I don't give additional mode, which will be default read mode. Okay, so I'll read this file in. So I just call this, easy for me to remember, is fn. Okay, reading this file in. Now I am starting to iterate over line by line inside this sequence.fasta file, inside these records. Okay, so the task asks us to read the file and print only the sequence, which means we'll ignore those tag, like we need to ignore these lines, but only print the sequence. Okay. So what I can do, so here is the time we need to give Python a condition to make decision for you. So here I just ask Python to check for every line, if the first space is equal to this greater than mark, I'll pass. I don't do anything. But if not, I'll print the strings, the records inside. So I just call these strip functions to remove unnecessary empty space, just for safe. Okay. So let's execute this one. So you can see now, I'll just ignore the tag part, but only print it out the sequence. So this is examples that you know you can read files and making decisions doing for use to only give you the records you want by giving Python the conditions. Like here's, I just finding, okay, there's a patterns, every record starting with a greater than mark. So I can take advantage of this by asking if the first place is a greater than mark. If not, I pass, yes.
So for the line, is that kind of a built-in for the files or like you, I mean, the for line in fn? Is it already know that line means which lines? That makes sense, because
Sorry.
this is a for loop, and I don't know if you can't use, instead of line, you use an L.
You mean this one?
Yeah,
Yeah, you can use different name for this one.
how do they know it's a line? Like you read it line by line.
So this is the default setting for reading file. So we know that will go by default, it will go in line by line. Yeah. So it's the default setting with the context managers.
Okay.
You can transform into different formats after reading the file in. But if this the default setting is that will iterate going over lines. Okay.
So once you have this open, like we're in a reading mode, like the for loop can kind of by default is like reading it line by line.
Yes.
Wait, but then if you put like per C, it'll go by character, right?
You mean
Like when you're doing it by character.
By
It's
character.
gonna go by line. It's gonna by like each part of the.
Oh.
string.
Yeah, but let's see. I'm not sure, but I think maybe this is a good way to see.
That's-
So basically these things will be this stuff. You can iterate every component inside. So for the text files, the default, they will go to line by line. So this way, there's different packages that can read the files into a whole read line, something like that. There will be the whole compact. But I'm just showing the default setting that they will go in through every line inside this fin. So the line here, I call this one is because by default, I assume this one should be line, but it's just easy for me, for people to see, we are going through line by line, okay? You can definitely change this variable names into L, into different stuff, okay? Mhm. So remember the sequence.fasta files will show up in the same directory. If you didn't assign anything here, they will show in this in the same directory like this, the current notebook where it is stored. Okay. If you are using the cloud, you can find this in the folder left side of the panel. Okay. Okay, so this one is we just trying achieve the task like printing out only the sequence. And we use the conditions if statement to, and we pass those lines starting with greater than mark. And we can also do another way by the continue keyword. Remember we learned early this today. So in this way, this exactly the same thing, but this time is like when it's encounter the lines, is starting with the greater than mark. We'll continue, which means we'll skip these lines, but go to the next cycle inside this object, the fin object, which means the next line, and then print the next, usually just print it. So this will show the exact same thing like we use for the pass. So it's different style, but achieve the same goal, okay? And we can also do this with another method. So this is a new method, but it's really useful. So again, we are reading the file in and iterate over every line inside. So I give a if statement saying if line it starts with this mark greater than. So this method will give you a output is the Boolean variables telling you is true or not. So you can see if not true, I'll print the line. So this way I'll call this building method to make decision if line, the first component is greater than mark. If not, then print this line. They will give you the same result, just the records. So you see we can do different coding style, but also all reaching to the same goal, like only print the records, but not the tag. Okay. So we'll have a 10 minutes break now. Let me know if you have any questions. And in next hour, we are starting to learn the how to write the functions and what functions will do for you. Okay. Yeah.
So you can also just name this and right, it's just so there's just like this individuals and after this morning and stuff. So is that why you called it something that very new because it's within the same yes, like and so it doesn't override the previous one or not override but like I think I do that you can use this and then I use that writing.
So this.
You're reading it, yeah, but then it's not for you, yeah, okay, but this.
And then multiply.
Okay.
Times 4.
Excuse me, yes.
Yeah,
What makes
so-
the file hostage?
And then it's the one.
So it's also balance with.
Just start.
It smells like it's bad.
Yeah, so it's just.
And then
But
okay.
right now the record is.
Or the step. And it's
So this is the
basically,
specific format for this.
Oh, you go.
Oh, for like secrets.
For rate.
Yeah, like it's this.
1, 2, those. I asked.
And then so
Yeah,
the
so
two
I
codes that
actually-
we had to run, it does the same thing. Okay, thank you.
And so, so I just did this, I did like 100 dollars. It's like 4, like 5. Right. And then like 1 raised to 5 by 2. So because so we're gonna be looking at that bottom numbers. Yeah. So okay, by 2. Then we can find 5. Basically, if what's 1 over. I think, so I think I also initialized the, I also initialized like count piece of it, and so basically I had like. So basically what I was trying to do is like every other, you subtract every other. Okay, and so basically the count is 0. Just. Yeah, and then every time we go through, then I add 1 to count. And what counts. Yeah. Okay, so it counts under percentage sign 2. So you're one of the piece of traction, so essentially. Yeah, I think we're and so then it just like, so
I think we did.
if
I
count,
And
if
probably fine.
like is divisible, but it's even.
No, I
Yeah.
like.
So like, so that's like a percentage sign.
Maybe each time, like at this
Like
point.
if there's a.
it's just like, Yeah, it's like, yesterday, or.
Then,
Feels good. You guys are this.
Oh,
then you.
so
I have a little memory of.
1.
No, I. It's from. Yeah.
High is high.
Yeah.
It's,
He's like, literally.
so like the first time you clear it's high, which is,
Probably yesterday.
but then you want to like keep going and keep.
And then I'm like, oh, I know it.
Yeah. And so then, and then you skip down and do go back to skip statement else, so count is divisible by 2.
But then they just.
Then you just do high.
I love it.
High.
I hear, yeah, I love it. And every time I say, oh, wow. And he said, every time you ask me the same.
No, you can just, you don't need.
It's like.
Oh.
Birthday, it's just like. Yeah.
So you don't need to even do that.
No, I feel like
So-
myself, like.
Because you're saying,
Like-
if it's divisible by 2, so if it's even, then you add, if it's not like otherwise, in any other situation, it doesn't.
If it's not written down.
So you don't even. So if it's divisible by
Like
2,
it's not.
if it's not, or like otherwise, do this.
I'm like.
So then that makes.
Like something.
Has the more dozens of.
Yeah, so that's the thing.
What is this? My house, what is this? And then I'm like, oh, I love.
And then, okay, actually, we got, and then we also have to
Like, especially when I.
In both of these.
I'm like,
statements,
oh, obviously I'll
equals-
remember that this goes here because.
So.
So the count goes up every. single time.
Yeah, and I'm like,
Yeah,
of course, it's like, this is such a logical decision.
Yeah.
Yeah. And then you just have like that nickname, but it's weird because like.
But-
Yes. It's actually like, right.
And then, yeah, and then.
Like, oh.
at the-
I remember, but then I'm like, oh yeah, I was like, my dad's like.
Okay, let's see if this is.
I'm like, oh, I remember, you know, I did this. I remember putting it there. Oh, my gosh, I was on- like, I don't know if I made it. That's right.
Oh, maybe, I think that's two, maybe make a little, sorry, this.
That's ten.
Yeah. Okay. We gotta, and it stopped.
That's really, it's like way.
It's like, let's see.
And I was like, I have to decide, who is this? And he goes, where do you guys invent like do you read this? It's like, my God, where do you say, but how do you know? Like,
So
we see the number and one number and it's right there. Like, well, yeah. Now, would you want to get out of work for me? Right. Some fancy bottle of all these sheets like, and then go.
Yeah, I feel like we're just like.
Okay. And then even then I fucked it up because it's really makes one of these things like so wrong. They were wrong. So I choose you. You do have one.
Oh, yeah. You have to say, oh, if there's, no. Yes.
I read the street word, five minutes, I think, but it's single sign. So it's already the first one.
Oh, and then we have to.
Their shit.
Oh, so, I've got that.
Oh, shit.
Okay, so.
Like, I don't know. You're.
So now I just.
Yeah. And I think, I guess that was sort of, these two are like, and this one is like, but I think this one's just the same in this basically, except for the line. But it's just, you just have, it's like, yeah, this side is just like what, like this is what, that's what that definition. Yeah,
Okay, what?
so, okay, so this is like, yeah, this is like the same, except for instead of going by two. slices.
I know four of the words, so like.
You know,
I got a really long, I saw the one. Got up.
but yeah, like multiplied by two.
You know, it's so funny how you said.
But otherwise, it's just
Just like.
it's very much just.
Other mountain, like.
It's the same concept. It's just-
Yeah. I feel like I know what I want to say. People like, they forgot to put the letters. Right. So. Yeah.
Yeah.
Like, isn't like a computer. Vision like that.
Oh.
Oh, I was like, surely that's the word. So that makes sense, really. It's not some random word. And then it was, even though stupid ones that are like.
Yeah.
Chips. Sounds like consumer shit, like, I was like, that's so obvious. Actually, yeah. And it is. Yes. It's just. That's what I'm saying.
Are you guys laughing? Okay. I would definitely prefer.
Yeah. So you want
Yeah. It's like.
I feel like it's easier to, like, you do the lab, and then you look at suckers. Versus like trying to like plan your experiments.
Aren't the division. This right?
Like, I feel like everyone.
And like, they were all. They're all like, I feel like they're all like. Like they didn't want to go eat, like they have slept in there, and so you'd always feel like, you know, like it should be like 6 or 7 p.m. And it's like, what are we doing? No, that's fine. That was kind of bad, yeah, so like I had like 10 rotation. Presentation, like 7 p.m.
Okay, let's continue our workshop. Okay. So, today we'll spend more time to work with functions because function is the really, I would say this the main building block for every program or the script. Okay, so you can think about Python as the unit inside the script. So you might design a program to do several stuff, and you can call, like, you can make those different functions manage for the specific part of the code, doing these calculations, print it out, and they will, like the name, they have the specific functions. That is how the Python function is working. Okay. So it's usually will be a block of the code that will be running when you call the function name, okay, inside the script. Okay, you can pass the data, which means we'll say is parameters or arguments into a functions, and the function do the job for this input, and then output in a style called return to show the result. Remember the building functions we learned, which is the print, right? So print, you take those strings you want inside and put them as an argument inside the parenthesis, and print, what they do is showing up in the console. They will print it out. So that is the function doing. Okay. So after function is defined, so you can call these functions anytime in any part of a specific script, unlimited times. So usually function is just like this one. They take the input and doing the work, doing the calculations, and transform or output into the styles, into the data types you designed. Okay. So that's starting to define our first functions. So usually is the context will be written in this format. You will call def, which is define. You will define here name of the function. For example, the print is the built-in functions. So the name of the function is called print. Okay. So you will give us unique name for your functions. Here I just saying is name of functions, and then the parenthesis. So inside this parenthesis, you can have parameters and argument. You decided as the input data for those functions, and then function will do something. And sometimes you will see a return at the bottom line, which means they will return a specific object. Or you can just call functions to work with the data and then not return anything. Okay. So there's these functions, there's no parameters and no return values, but this could be exist, and most of the time they do. They can take several parameters and output several stuff. Okay. So let's see, design these functions to call, like say hello. So what this function do is they will, once you call this function say hello, they will print hello there. Okay. So let's define this first. You need to define it and then call it. Okay, so this also written in order. So I define this say hello functions. Every time I call this one, they will print these lines. Okay, So after I define, I just call, say hello, no parameters, okay? And no return, but just print stuff, okay? So I define in life and then I call after, you can see they will print the lines several times. So you can feel how useful this one, the function is. You don't need to repeat doing the same coding, but you can just put everything inside, write them into a function. And if you have repeated work, just using different parameters, and then you can call functions to do it. Okay, so that's why function is really a name inside. And once they take this, once I call this say hello functions, they will print hi someone. So remember we have learned this format method yesterday, which will put the parameters here and into and printing to hi someone else. Okay. So this is the functions with one parameters. So let's define this function first by executing this line of codes, okay? Once I define it, then I calling this, you can see I'm calling functions by saying hello to different person. So say hello to Mike, say hello to Sam, say hello to Tom. So once I call these functions, they will print accordingly. So I'll say hi to different persons by feeding in different name as parameters. So that is what function is doing. Okay. Another example shown here is we can, like here's I call say hello different times by input different names. Okay, I can also do the same work by looping with these functions. First, I'll make those names into a list of friends. Okay, you can see these friends will include 4 names, 4 people. And then I'll say hello to them one by one. Okay, so I just looping over this friend and then say hello. Okay, so here I just call this, execute these lines, and then you see they will, once they go over every friend, they will say call the functions and print it out those hello message. Okay. So this one is we call functions with parameters, and now we can also have functions that return values, which formally defined as output of the code. Okay. So this one, I'll define a function called addition. So you can see by the name, it's doing the mathematical additions for 2 stuff. So I'll give this function to take in 2 parameters, A and B. And what this function do is they will return the values to be A plus B. Okay. So we first define these addition functions. And then here I assign A variable to B2, B variable to B3. And then S will be a variable that store the output from the addition function running with A and B. Okay. And then print the sum of something and something is something. So the format will be A, B, and S inside this curly bracket. Okay. So let's call this. You can see the sum of A equals 2, B equals to 3 is 5. Okay. So you may notify it's like I designed the I assign the variable names to be exactly the same thing as the defining here's. But basically you can change this A and B into different names. The A and B is only meaningful inside the specific function block of code. Okay. We can even break down the complex issues into different subtopics by calling different functions. So that will build those hierarchy for the code. And then function you can see is definitely a block of the code. You can see those indentation levels inside the functions, and then will make your programs look more organized. And every time you see these define keywords, which means there's a function defined here. Okay. Let's see. So let's see how function will organize your code. First of all, the thing we want to say hi to different people. So the original way, the more easy way, I would say, is just to print different times. So it is doable if you just have a few on your list. Okay, you can just call print and say hi to, and then change the names in different lines on your own, and they will do the jobs. But this is not efficient if you have 100 people and you don't want to write this and in 100 times copy and paste. So we'll define a function, say hello with the name. Okay, and then print out the format. So we've already done this before. Define the function first, and then say hello to this person by feeding the name as the parameters. Okay, but what if we have 20%, 20 friends inside this group? So this is not efficient to do so, right? Even though you could define the say hello functions, you don't want to call this 20 times by feeding different parameters. So you can, so let's see, we can also make the feeding process into a specific functions. Okay. So we do this, we define a say hello functions as before. So this will be exactly the same thing like here's. But what we do is we say hello to all. So this say hello to all will be taking a parameters. So these parameters will be a list. This list will be the 20 friends you have. So in these functions, for every friend, I say hi to them. Okay. So for this two lines, so we can define friends to be 4 persons here. And then I just call say hello. So you call say hello. Sorry. Okay, I haven't defined this. Remember to always define before calling them. So you see this say hello to all. Inside these functions, they will call the say hello functions every time. Okay. So once you do this, they will, once you call the final, the summarize functions, they will do the job. Okay. So basically we'll put the repeated part of the coding into a function. So this say hello is the say hi part of the repeated works. The say hello to all is the part like we call different names. We are doing this repeatedly. Okay. So we put those repeated works into specific block of the code by defining them into a function. Okay. So the main task for function is that they keep processing those repetitive works by taking different parameters. Okay. Remember, we have an examples the day before yesterday. We try to calculate Celsius to Fahrenheit, how to convert the numbers, right? So you can see this is a fixed formula showing up here. So Fahrenheit will be Celsius multiplied with 9 and divided by 5, and then plus 32. So it is a defined equations, defined converter. So we can write this one, the Celsius to Fahrenheit converter, into a function. So asking the function to do the job, okay, by input different Celsius degrees. Okay. So now, like, we can do this calculations with a way of functions. So this time, I define C underscore to underscore F. So usually when we do a coding, we wanted to make sure it's also human readable. So that's why when I define for the function names, I can sort of feel what this function is doing. So I'll just, because this name must be unique, and it need to be unique and it need to be interpretable for you. So I just define this function name to be C to F. So it's easy to interpret as Celsius to Fahrenheit. So this function will take in one parameters. So the parameters will be the Celsius degrees. So it will be the C showing up here. So what this function do is they will do the mathematical works and calculating for the Fahrenheit degrees. And then return these Fahrenheit degrees as an object. Okay. So by having this functions, we can call this converter several times in many ways. And anytime you have a Celsius degrees to come to transfer, and you can just call these functions and do the work for you. Okay. So let's have this for taking an interactive input. So remember, we go through several times in the past 2 days. We can take the input from the user end by calling the input functions and asking for the input degrees in Celsius. So this input is a strings. We casting them into a number. So this time I'll took this as float. Okay. So I'll asking the users to give you the input. And then once I take the input, I'll call the functions to make the Celsius to Fahrenheit conversion. And then they will store the value into F and then print the Fahrenheit degrees out. Okay. So we can call this input degrees in Celsius. Let's see, we can say 36.5. Okay, I haven't defined. Okay, make the same mistake again. You need to define it first and then call the function. So this time they'll take this input, call the function to do the conversion, and then finally print out the Celsius, the Fahrenheit degrees. Okay. So you can also incorporate the functions in other ways, like reading input from the files. So this one is we reading input from the user end, and then putting the output to a files by the reading and writing things we just learned this morning. Okay. Let's see these examples we do like the day before yesterday's. We need to write the functions that test the numbers with the name test numbers and checks for those conditions. If the number is divisible by 3, 5, or 7, but not by 15, 21, 35, or 105. So we need to write the functions to do that. Okay. Use this function to find the sum of integers that pass the test in range 1 to 100. Okay, so there's one thing to write a function and then use the functions to finding those numbers passing this test between 1 to 100. Okay. Let's go through this one. So this is what I do. So I'll define the test number into a functions that will take in an input, an integer as an input. What this function do is that will return whether this condition give you a true or false. So the return value will be a Boolean variables, right? So first, I'll make sure they could be divisible by 3, 5, or 7, but not by 15, 21, 35, or 105. Yes.
You probably backslash. Is that just how?
Yeah, it's just, so this one is make sure they will continue reading to the next line. But I wanna make sure like all of the, show in the windows I can visualize. Right, so, if this, I don't put this, this will be a really, really long line. So I need to screw over, yeah. But if I just, if I don't put this line here and I make them into different lines, the interpreters will not take it, yeah. So you need to have this line break for the interpreters to read continuously to the next line. Okay. So I first define this test number. They will take in a numbers and make decision is this true or false statement. Okay. So the second thing I need to do is trying to looping over 1 to 100 and output those numbers that fit this criteria. So which means that will pass this test and give you a true output. Okay. So I'll assign a accumulative variables and starting to looping over integer 1 to 100. So I need to put into range 1 as the start, 100 no 1 as the stop. Okay, so I'll go over 1 to 100. For every I test whether this is a true statement. Okay, if yes, I'll print these numbers and I want to put them into one line. So I'll add additional argument with and to be comma. Okay, and once it's done, as will be adding with these numbers. The sum of integers, that's what we are going to achieve, right? So once it's done, I'll print, go to the next line and print the final sum of these integers. So just execute it. So these are the numbers that pass the test. And the sum of these numbers is 2008. Okay. So let's go to task 2. So the task 2 is trying to also dealing with some numbers. You might be surprised, like 213 is the first year since 1987 that the year is composed by 4 distinct digits. Okay. The years 2014, 2015, these things will have 4 distinct digits. Okay. So given the year, so you might have a random year showing up. What is the next year's with the 4 distinct digits? So by breaking down these questions, the condition is you need to check if the 4 digits are different inside the years. And you also need to take an input that might be a random numbers. And you have to go continuously iterating until you reach the criteria, like the next year showing up with 4 distinct digits. So there will be the 3 main problems we need to solve. So the input consists of an integer y representing the years, the starting years. Okay. Output will be a single integer d, so they will be composed by 4 digits, which will be the next years after y with the 4 distinct digits. Okay. Let's have 2 minutes so you can write your ideas down below and we can come back and checking whether you are on the right track. Okay. So let's see how I solve the problems. Remember, you can always have different answers, different ways to achieve the same goal for this kind of coding task. Okay. So I try to break down the questions into two functions. So the first functions is I'm going to see if the given year is composed by 4 distinct digits. Okay, so you can imagine this n, the parameters will be any random years coming in. So inside these functions, what they do is checking if it's 4 digits. So first I'll give an empty list. So this accumulative vectors, so that could store for the things inside. And I is equals to n. I just need to iterate over this one by doing work for every digit inside. Okay. So what I do is while I is greater than 0, I assign a d variables to be the remainder of I divided by 10. So it's based on our numerical systems, it's decimal. So I'm going from the, if this is 4 digit, I'm going from the right-hand side of that digit. I'll see the remainder of this value. So this will be the d. So if d in the L, I'll return false. But what this means is like L will starting with an empty list. If d is already in L, which means this digit is repetitive. Okay. So so if d is already in L, these functions will return a false, which means the given years is not composed by different digits. At least some similarities is already encountered. Okay. So else I'll append this d, the remainder, into this empty list. So finally, you will see the if there's for the year like 2014, they're starting from 4, 1, 0, and 1. Okay, that will be inside this list, and it's totally 4 different digits. So while loop, what they do is they will iterating over by the 10 decimal systems. So every time for 1 digit, I'll divide by 10, and so I will be equals to the quotient from the 10 division. Okay, so that is the thing this one do. So once this pass without problems, I'll return true, which means this year's is composed by 4 distinct digits. Okay. So in the next functions, we're trying to find out the next year from n that with 4 distinct digits. Okay. So we are starting to iterating over. So you can imagine we are probably doing an indefinite looping because starting from now, we don't know when this cycle will break. We don't know when we'll find the next year's that it was 4 digit, that is with distinct digits. So we are doing a starting from the next year, so there will be the n plus 1. Okay. So while not all distinct digits, so they will checking starting from the next year's. While not true, I'll keep adding 1 more year, going the next year, going the next years. And finally, I'll return n. So it will be the next years after the given years that was the 4 distinct digits. So again, I have to define these 2 functions at the beginning, and then starting by calling the next year with 4 with distinct digits, okay? And with the given number to be 1987. Okay, so I'll run this and that will tell you after 1987, the next year will be 2013. That this is composed by 4 different digits. Okay. Any questions? Okay, let's do this triangle challenge. So remember we have this print triangle task yesterdays. We achieved that with a nested loops approach. So now it's like we're going to create a print triangle functions that will print patterns like this one. Okay. So you can see is also iterating over numbers and given a specific end from the user end. So the hint will be create a print row functions that use it inside the print triangle functions. Okay. So we'll have 2 minutes, so you have time to write your code. Okay, let's come back and let's see how I solve this problems. We did this, we achieved this goal yesterdays by doing this with nested loops, remembers. So what we did yesterdays was we taking the end from the user end and to be the numbers, we decided to print it out. So for end will be the end of rows. So it will be the outer loop will be the end of rows. We're going through every component inside. And for every end inside, I'll do an inner loop. They will starting from the specific positions inside the outer loops and then looping overs. And I'll print J for in that specific rows and then print a empty space as the separators. And once we finish the inner loop, I'll go to the next line and starting to go over another items inside the outer loop. So that is what we did yesterday. So we can have an input here that will print out the triangles exactly like what we want. Okay, so now today, since we are learned how to use functions, so we are doing this in the function ways. Okay. So first of all, I'll define a function called print row. So print row will taking one argument from the user give, and for every component in the list from 1 to that numbers, I'll print that component and space with one empty space. And then after this, I'll go to the next line. So that is the print row functions. But I want to print this in the 2 dimensions. So I'll need to put this with the print triangle. So print triangle also take the same numbers as n. So inside these triangles, I'll looping over the same range. And then for every component, I call print row. Okay. So basically, I split this this inner loop and outer loop into two functions. Okay. So I'll define this and then print triangle 5. So this one will give you exactly the same output as the nested loops. Okay. So the next exercise is write a functions that compute the factorial numbers. You can see the factorial numbers here is the multiplications from 1 to the specific numbers that you decided. Okay. So you can see this is the same works because it's repeatedly doing the multiplications. So we can just solve these problems by defining a function called factorial loop. Okay. So the factorial loop will taking one argument n, which is the end of this factorial series. So the starting values will be 1. So this is the feature for factorial, starting with 1. So for every component inside 1 to n, so f will be multiplied with that numbers. Okay, so it's multiply and equal to, and keep updating for the f. Okay, and for every levels I'll print it out, but finally I'll return the factorial numbers. Okay, so I can just define this factorial loop and then call this. Okay, so I'll print 1 multiply with 2, and then 2 multiply with 3, and keep going, and until the last one will be 5. Okay, so I'll return 1 and 200 from this factorial loop function. Okay. So remember we have a leap year test days before. So remember we are trying to see if a given year is a leap year. So leap year has definitions. This should be divisible by fully divisible by 4. But if this is century years, it need to be divisible with 400. So that is the definitions for leap years. So here we want to solve this problem with function. So write a function called is leap year that will check if the specific year is a leap years. And then using a loop, compute the total number of leap years between year 1999 and year 2010. Okay, so and modify the program to output all the leap years into leap_year.txt. So you will be fluent with the skills by defining the functions and then loop, find out the result, and then writing the output inside a document. Okay. So let's have 2 minutes brainstorm and we'll come back and see my approach. Okay, so let's check if how I would do the solve these problems. So like the instruction saying here is write a function to check if a year is a leap years. So remember we do this yesterdays. We first check if the division, the year is fully divided by 4 by calling the modulos operand. Okay. So once this give you zeros, I'll go to check if this is century years. Okay. Century years means there will be fully divisible by 100. So if this also met, I will check if this year is divisible by 400. So they will return true. If not, they'll return false. So these levels will check if this is a leap years with century years. Okay. And this one is, if it's not century years, I just check if this divisible by 4. So you can see this is leap year functions taking in one parameters is the given years. They will return either true or either false to be is this leap year or not. Okay. So the second task here is using a loop compute a total number of leap years between this range. Okay. So I am looping over the range and starting with this leap years that accumulated to be 0. So for every years between the range 999 to 2010. So I check if this is a leap years. So if this is a true statement, which this is a leap years, I'll add 1 to the CMT. Okay. So I'll print it out how many years are leap years in between this range. Okay. So this one will tell us like there's in total 245 years that are leap years between this range. But the third task is asking you need to modify the program to output all leap years to a file called leapyear.txt. So we already have the is leap year functions. So I need to just open a leapyear.txt files in a writing mode. Okay. So this year, this will be the writing file. So I give them a name to be F years. So I'll go iterating over these years from 999 to 210. Okay. So if this year is the leap years, which means if true, okay, if true, F will write, the text context managers will write this year in a string to this leapyear.txt. And you need to go to the next line every time when you have a new record. Okay, so I just execute this and you can find these files in the, again, the same directory as the IPython notebook. So you will find out here, they will give you all the leap years within the range you give. Okay. Last exercise here, let's create functions that check in two lists if they have at least one element in common. So from this request, you can see probably we're taking two lists as parameters for a specific functions. That function will check if there's common component inside. Okay. So the first do some trial. So I'll just give a list 1 and a list 2. There will be a list of integers. Define it first, and then writing a function called has something in common. So this function name is telling you, is checking if there's component in common. So they will taking two lists as parameters. Okay, so inside these functions, for the first loop, I am looping over every component in list 1, and then looping over every component in list 2, and then do the decision by calling the if statement if I1 equals to I2, which means they are similar items. If this criteria meets, return true. So if this nothing happens, they will return false. Okay. So finally, I just define it and call this function to check the L1 and L2 if there's something in common. So it will return false because there's nothing shared between these two lists. Okay, so this is the usage for functions, which is really important and very useful for coding. So I think we can have 10 minutes break now, and we are starting to learn a new data type code dictionary in the final hours. And during this break, please, can you do this survey for me? Yeah. I'll leave it on the screen. We'll come back in 10 minutes.
Picture this is new.
Mhm.
So for this,
The
do you like, yeah.
You
it's on
can
the-
just give the random.
Okay, so
Yeah.
can I just, yes,
Yes,
okay,
you can just assign that. I just need to make sure like you do this. Fine.
okay,
Yeah.
good, no problem, thanks. Which is-
That's what I think.
Yeah.
What the is this again?
Think.
Yeah,
Sure. No problems. Probably I can just forward to you.
Yeah.
Okay.
That's fine. Oh, should I get a big?
Oh, I should have three. Yeah, can just forward to you. Okay, thank you. Let's see. Hey, Lloyd. Okay. Thank you.
That's.
James. Eliminate, you mean something like this?
Yes,
Okay.
it's an easy way to. just
Yeah.
run through.
I believe I did them right. I'm not entirely sure about this one.
I think you're doing it right.
I just need to put this down here. Yeah, this red. This. Okay,
Mhm.
thank you.
It's good.
And for the assignments for today,
Mhm.
if we do them, do we send them to you or just do it for
You can
practice?
send it to me.
Okay,
Yes. You cannot scan it.
My phone doesn't make them getting.
Oh. This is fine. Let me see if it how to do it.
No, I would not.
See if I can.
Absolutely.
I just.
Oh, I could, yeah, I could do it real, I'm sorry. No, no, it's not very, it's not very bad, just.
Thank you so much.
There you go. Because it's on your account.
It's a market.
Yeah, I'm sorry. It's not. It's not.
So let me just.
You can maybe send the link to me and then I'll.
I don't think it works, but I can email.
I really have to find it online. There's something. Oh, okay, yeah, maybe it's not. Yeah.
Okay. Should be
That's it. Oh, I had this. I had this. Sorry, you can, I'll figure it out. This-
I was gonna go, but I'm just I wasn't curious. What's that?
Wait, is the term part or is the That's not in his parts, but one in the. Oh, it's good. Okay.
Okay, so let's start our final part of this workshop. So we've learned different data types, strings, numbers, and also list in the past 2 days. And now we are going to an indexed data types, which is called dictionary in Python. So dictionaries are is also a collective data, but that will store key and value pairs, which means you can source a specific value by their key. Okay, so it's very useful and efficient for finding specific element in its collections. So the context for dictionary in Python is here div short for dictionary, so it will be equal defining as dictionary will be inside a curly bracket. Okay, so the curly bracket inside will be different records, key and value records, and the key and then column, and then after the column will be the value for that specific key. Okay, the keys will be a unique values. So every time you can go to that specific key and find what is the corresponding values for that specific record. Okay, so here let's go through some examples. So here we got a D, short for dictionary, that is assigned with 4 records. These 4 records will be name, age, position, and degree. Okay, so you will see their name, age, and corresponding position and their degrees for this person. Okay, so defining this first, and then we can print it out what D looks like. So basically, when you're printing, you will see this curly bracket and column, which means this will be a dictionary object. So in this record for this specific person, we have her name, age, position, and degrees. Okay, so we can source the specific records for this person's and after calling the keys. Okay, so once you got a large dictionaries, you might want to know what are the keys included in these collections. You can just call in with the keys method. Okay, so you put dictionaries here's dictionary name here's and calling dot keys. So there will be list all of the keys inside this dictionary. Similarly, you can also find the values with the corresponding keys, but not here will be in orders, and they will call in the values method. So they will tell you we have values like this one in a list format. Okay. And you can also just getting the items by calling the items method. So they will show you the key and the value in pair. And this tuple will be stored inside a list. Okay, so this is the way we can quickly go over what are inside a specific dictionaries. Okay. So if you want to go to and source the specific values for that keys, you can use the square bracket like this one. So the dictionary and the bracket, and in the bracket you give the key name. You will show you the value for that specific keys. It's very similar to the index, the context in the bracket, but for dictionary, you need to put a key inside this, and it will go to the pair and finding that specific values. Okay. And also we can source different, like we can print the degrees by calling the degree key. Okay. So dictionaries are also mutable, which means you can change the values correspondingly to a certain key. So we learned about the mutable data types like list before, which means you can change the items in place by the index systems. So in here, we can change the degree category into the value. You see here, before it will be bachelor's, but now I want to assign it to be MS. So after I change these values by calling the specific keys, giving them a new values. So they will change in place in the current dictionaries. Okay. So once you call this all collections, you see the dictionary structure has already been changed. Okay. So which means dictionary is mutable. It's a mutable data types. Okay. So imagine, so you have this kind of index data, so it's very easy for you to go to specific locations and finding specific, for example, this one you're finding interested, you want to sort people with the same degrees, find people with the same position if you have multiple records, right? So you can also iterate over a dictionary with their keys with the for loop we learned before. So you see here, we can go over for key in the key list inside these dictionaries. Remember, this one will give you a list. Okay. So for key in this one, I'll print the record into this format, something, column, something. So the first one will be the key, and the second bracket will be the value. So value will be this form. Okay. We can iterate over this dictionaries, so they will print name, column, name, age, column, age. So you can iterate over the key pairs. Okay. You can also iterate the dictionaries with the items method. Okay. So remember, the items method will give you a key and its values in the tuple in the pair. Okay. So there will be two values coming from this items. So we assign its temporal name to be K and V. The first one will be the key. The second one will be the values. And we want to print the key and values for every component inside these dictionaries. So we can see this one. We can see this K corresponding to this index and the V corresponding to these values. So you can iterate with keys or iterate with the items method. Okay, so this is the basic concept for dictionary data structure. Okay. So let's go familiar with some of this dictionary usage. So here I got a example table showing up here. I want to create a dictionary based on this gene expression table. Okay, want to compare the gene expression level between sample A and B. So you can see this is repetitively going over the pair shown here, okay? And output a file, so we need to write a file that lists genes overexpressed, which means it's more expressed in sample A than in sample B, okay? So we just have 5 records here, so we can just put them into a dictionary by assign these values. So here I got this gene expression dictionary. So these dictionaries, they will have gene name as the key, gene 1, gene 2, gene 3, and gene 4, something like this. And I'll store the expression levels in sample A and B in a list. Okay, so the values could be several types of data types. They could be a strings, they could be integers, they could also be a list. So here, because it's in orders, so I'll put the expression level for A and B in this format. So this is the defined dictionaries. So we can print this out to make sure like we already designed this gene expression dictionaries. Okay. So the keys will be the gene name, gene 1 to gene 5. And the values will be the expression levels in A and B in pairs. And let's see the items going through. There will be the gene 1 and the expression level for A and B. Okay. So the second task is compare the gene expression level between sample A and B, which means we need to iterate over every genes and compare the expression between A and B. Okay. And then we need to store those gene names overexpressed in sample A. So first I'll create a empty list, so which is safe for the use in the futures that will, once we find some genes that is overexpressed in A's, I'll add that gene name into this empty list. Okay. So for gene in the gene expression dictionary keys, which will be gene 1 to gene 5. Okay, so we are starting to compare the values by calling the if statement. Okay, so we'll go to the expression levels for A, which we know that will be in the first position, and the B in the second positions. Okay, for that specific record. If this is a true statement, which means this gene is overexpressed in sample A, I'll append the gene name to this empty list. Okay, if this is not a true statement, I'll just pass. Okay, and finally, I'll print those gene names that is overexpressed in sample A. Okay, so that's just to run this one, and that will tell you gene A only had overexpressed A list, only have one gene, which is gene 5, that's showing overexpression in A than in B. So you can come back to see that if this is true. So when going through, and you will see, yes, gene 5 is the only one that overexpressed in sample A than in sample B. Okay. Questions? This is for dictionary assign values and going over every component by iterating the keys. Okay. So remember, we have this sequence FASTA in our first text today. So we have created a file called sequence.fasta in today's task A. So this FASTA file will be looking like this with a tag and this corresponding records, the tag and the sequence. Okay. So now I want to read file into dictionary. So we need to use the with open keyword to read these files again. And I want to put the sequence name as a key but the sequence itself as the values. So it's easy for us to source from the record to the values. And then write a function that return the reverse complement of this sequence. Okay. And finally, I'll write the reverse complement sequence into another FASTA file called reverse sequence.fasta in the same order, like this one, which means they will starting from sequence 1, sequence 2, sequence 3. And you need to add the tag with the prefix as reverse underscore. So for example, the original sequence 1, once we do the reverse complement, I'll put the name into this one. Okay, so let's break down these questions. You need to read the file first, but you need to read it into the format of dictionary. So that's the first task. The second one is like this one, writing the function doing reverse complement. And then finally, I'll put those reverse complement records. So if you don't know about reverse complement, so it's for DNA sequence, usually they will be composed by A, C, G, and T. So the complement one will be A will be complement to T, C will be to G, G will be to C, and T will be to A. And you need to do this in reverse order. So that means the reverse complement. Okay. So let's have 2 minutes to brainstorm. How would you deal with this task? Okay, let's come back to here. So let's see how I solve these problems. So first I'll assign, so we decided to read the records from the files into dictionaries. I first given 2 empty lists. One is the sequence names. One is sequence itself. So there will be 2 empty lists, okay? So I'll read the files in. So with open sequence.fasta, and this is a reading mode, okay? So So they will be treated as FN in the downstream. Okay, for this lines inside these files, if this line, the first place is a greater than mark, I know this one will be the sequence names. So I'll append the sequence names. Append what? Append this tag starting from the second position, which means I'll skip this greater than mark, but only keep the record. Okay. Strip is just in case if there's extra empty spaces showing up. Okay. So if this is not a record, which means there will be sequence themselves, I'll append these items in this line into the sequence themselves. So after we're going through this for loop, we'll have two lists. One is sequence names, one is sequence themselves. And then I'll assign them into dictionaries. Okay, how to assign them is I'll go over every items inside the sequence name. So you can see these two lists will be in the same lanes, right? So for the dictionary, I'll put the sequence names as key, the sequence itself as the value. So after this one, I will have the sequence dictionaries with the name as the key and the sequence as the values. Okay, so that's just to execute this. And then we can now source the specific record inside the sequence dictionary. So let's see the sequence 1, that will be corresponding to ATGAT. Okay. So that is the first task, is to read the files and then put the reading input into a dictionary. Okay. And the second task is we want to do something to this sequence. We want to do reverse complement to this sequence and with a function. So there's rules for reverse complement. So you will put every rules inside these functions. Okay. So you see, I define a reverse complement function taking in sequence. Okay. In these functions, we make a dictionary. So this dictionary I call this reverse complement dictionary. So which means when I encounter A, I can call T. When I encounter C, I will call G. Okay, something like this. So we first need to do the reverse of the sequence. I'll do this from the end to position 0. Okay, so after this, the sequence will be reversed. And then in this reverse sequence, I first create an empty list and then iterate over the characters inside the sequence. Okay. So for every character, for every nucleobases inside the sequence, I do reverse, I do the complement part, which means I'll source these values. If I encounter A, I'll turn this value into T. Okay. So, and then I'll append this complement nucleotide into this RSeq list. Finally, because it is a list, I need to join them into a string. Okay, so I'll use the join method. So this join method will be no delimiters, will be empty. And by joining those components inside this RSeq list and still using the same name. So this one will become a strings. Okay, so this old stuff will be defined in the reverse complement function. Okay. So the third task is we've already reading in the records into dictionaries, and now we need to reverse complement every sequence and then write this reverse complement sequence into a new file. In the new file, the sequence need to be reverse complement and the name need to be appended with a reverse underscore prefix. So here I just open a new file called reverse sequence.fasta. in the writing mode. Okay, so now I'll go through every record inside the previous dictionaries we made. Okay, for every key, every record inside the dictionaries, the sequence will be the sequence dictionary with the key name in the bracket. So there will be the sequence itself. And I need to make reverse complement. So I'll have this new seq called rseq that going through the reverse complement function. Okay, and storing this value. And I'm starting to writing out this record. First line, I'll read greater than reverse underscore. So this is the new prefix we need to add. And this I means the keys, the seq1, seq2, seq3, right? So this, the original seq name, and then go to the next line. And then the next line, we write the reverse complement sequence. Okay. So we'll just execute this one. So again, this file will pop out in your IPython directory with this specific file name. And now let's check if we are doing this correct by reading the files in. So this new file we just created and saved, we just read it in and reading in with different lines and see if this is the reverse complement sequence. So you can see we got this prefix for specific sequence A. And this is the prefix for specific sequence 2. So there will be the reverse complement for the sequence showing up here. Okay. So this is the usage for dictionary. So this is a good method to quickly go to a specific key and value pair. Okay. So the final part of this workshop is like we're quickly going through how to actually running script. So in the class, because it's the introductory class, so we have this Jupyter Notebook, which is an interactive distribution for Pythons. So inside this interface, you are already in the Python environment, okay? But if you are going to your command line in your laptop, you need to make all of every line of the code into a file with the .py as the file name, and then execute that file to run with Python. So that's why we call this running script, okay? So in Jupyter Notebook, if you have this exponential mark at the very beginning of this coding block, this will be making this environment the same as the command line in your terminal, okay? You can just type this one, exponential Python with _ version. That will show you what the Python version you have now. So on my end, I have Python with 3.11.5. Okay. But this one is the output from your command line, not Python. Okay. Okay. So now that's trying to write a script in the that Python could interpret and executable. So we'll open a new file called myfirstscript.py in the writing format as an fout. In this file, first thing I'll just print this is the output from my first script. So it's just a test. So let's just execute this one. So this file will be showing up in the here. There will be, okay, print, blah, blah, blah. So you see this one is the language we use in Python. It's calling the print functions and print what? Print, this is the output, blah, blah, blah. Okay. So you see this is the context for a Python script and save in the .py name. Okay. Now let's see what is the content in this command line. We can just use the cat command. So you will be more familiar with this if you take the Intro to Unix class or you can just Google how to operate in your command line. It's very uniform command you will use. So CAD means they will show up what the document have. So once you execute this in the command line, they will show, okay, this file contains this print. This is output from my first script. Okay, so let's run this program with Python in your command line. Now you need to call Python with the in the command line. So there will be a exponential mark here. What they are executing is this file. Okay, so once we execute this, they will showing this in your terminal. Okay, because this is the output from the print functions, and you are asking Python to read these files, execute this program, and then showing up the output. Okay. Okay, so we've going through every part of the workshop, and I hope you enjoy it and learn something new, something interesting. So there's 2 additional assignment for students. For today's not mandatory, but you have to email me your day 1 and day 2 assignment by next Friday. Okay, if you have any problem, just let me know, email me. And then thank you for joining for 3 days, this long workshop. Okay,
Thank you.
thank you.
Yeah, I'm gonna actually.
Yes.